This tutorial is for 6th grade, Module 4, Lesson 15. In this lesson, we're going to plot inequalities onto number lines. To begin with, we're just going to look at some basic information and how you would plot it on a number line. The first statement says that Alexis is 12 years old. In order to show this on the number line, I simply have to put a dot on the 12 to represent her age. If I go to the next question, this one says Roger is 13.5 years old. So if I look at that number line, I know that the half will be between the 13 and the 14, so we're going to plot that there. So that's how I would plot that basic information on a number line. Now let's look at this statement. This one says the forecast is 3 inches of snow or more. So in order to plot this on the number line, we'll start with the 3. So I'll put a dot on the 3 inches because we know that the forecast is at least 3 inches, but we could also get more than 3 inches of snow. Now I wouldn't just plot a point on the 4, the 5, the 6, and so on, because what if we got 3.5 inches of snow or 3 3/4 inches? All we know is we could possibly get some number, whether it be a fraction or a decimal as well, greater than 3 inches. So instead of putting a bunch of points on my number line, I'm going to leave the point on the 3 as my starting point, and then I'm going to make an arrow that runs through all the rest of the numbers greater than 3. So this is what the graph looks like now. We have the 3 inches as our starting point, and then we have this arrow showing that we're going to cover all the numbers greater than 3. And because it has an arrow at the end, it means we're not going to just stop here, that arrow would continue on through the number line. So this number line is showing us that the amount of snow, which we'll call X, is going to be either greater than or equal to 3 inches. Let's look at another example. This one says that a child's ticket is for children less than 7 years old. So imagine you're going to a movie or an amusement park and you're paying a different amount for a child's ticket. Well, that's only valid for children who are less than 7 years old. So to plot this, I wouldn't put a dot on the 7 because they have to be less than 7. To show this, I'm going to put an open circle. That open circle means I'm not counting the 7, but I'm going to count everything up to the 7. So we need all these ages that are less than 7 to count for that child's ticket. So again, we're going to put an arrow in to show all of those numbers. Plotting it this way shows me that all of these ages that are less than 7 would be considered a child's ticket, but the 7 itself would not. This is telling us that the age of the child needs to be less than 7 in order to qualify for the child's ticket. The next question says, you must be taller than 48 inches to ride the soaring screamer. That means if you are 48 inches tall, you cannot ride the ride. So we wouldn't put a dot on 48. Again, we'll put an open circle on 48, meaning we're not going to count 48, but we're going to count all of the heights that would be taller than 48. So we're going to put that arrow pointing to the right to show that we're going to include all of those heights after the 48. So this plot is telling us that the height of someone who wants to ride the ride has to be greater than 48 inches. The next example says a person must weigh 120 pounds or less to ride the bike. So we are going to include 120 pounds in our graph this time. So I'm going to put a completely full dot on the 120 and then draw my arrow pointing to the left to show that any weight under 120, counting the 120, would allow that person to ride the bike. And this plot is showing us that the person's weight, which is X, needs to be less than or equal to 120 pounds. Now let's plot some inequalities not using a story situation. This equation says that our X is going to be less than -3. That means we're not going to count the -3, so that's going to be an open circle, but we're going to draw an arrow pointing to the left because everything to the left of the -3 will be less than -3. And this is how we would plot that. In the next example, we want to plot our X so that we're including everything that is greater than or equal to -4. So we are going to count the -4 in this one. And then we're going to include everything to the right because everything to the right would be greater than the -4. So in this plot, we're counting the -4 and everything greater than the -4. Now let's look at some number lines that have already been plotted, and we'll write the equations to match. For the first one, I see that I start at 3 and I'm including my 3. So that means my X is going to be greater than, because I'm moving to the right, greater than or equal to the 3, since I'm including the 3 on my graph. In question B, I'm at -2, but I'm not including the -2 because I have that open circle. This means that my X is going to be greater than -2. I'm including everything to the right of -2, but I'm not including -2 in this equation. And we'll look at two more. For this one, I'm starting at 5, but I'm not including the 5. I'm including everything that's less than 5. So my X is going to be less than 5, but it's not including the 5. And for my last question, I am starting at -5. I'm going less than -5, but I'm going to include the -5 this time because of that filled in dot. So my X is going to be less than or equal to -5. So the biggest decision we have to make when plotting these points is, are we going to use the open circle to show that we're not including a number, or the closed circle to show that we are including a number?